Today we're going to be practicing simplifying radicals. If you had me for Algebra 1 or Geometry, this was taught towards the end, so for some of you it might be review. So when you have a radical, it's just another name for a square root. And what you want to do is you want to break it down to all its prime numbers. So for example, the smallest numbers that it can be divided by, like 2, 3, 5, 7, etc. When you're simplifying radicals, you're just going to find all the prime factors. Once you find your prime factors, you're going to take out each pair of same numbers. And then that goes in front of your answer. Whatever's left over remains under the square root. So let's go ahead and look at some of these. Here we're going to simplify the square root of 48. So you're just going to pick two numbers that would multiply to give you 48. So you could do like 12 times 4, 3 times 16, 2 and 24, etc. Up to you. Let's just use 4 and 12 for now. But whatever comes to mind first. And then neither of these are prime, so we're going to break it down smaller. 4 can be 2 times 2. 12 can be 2 times 6. 2 is prime, so I'm going to leave it alone. But 6 is not prime, so I'm going to make it smaller. 6 can be 2 times 3. So when you're looking at your little tree, you ignore the big numbers. You're only looking at the prime numbers. So here the 4, the 12, the 6 don't matter. It's just the numbers that are prime. And now your goal is to take out the pairs. So for example, here I have a pair of 2's. Here I have another pair of 2's. If there's another pair, you multiply them. And then whatever's left over is going to go under the square root. So here we have a leftover 3 that doesn't have a pair. So it remains under the square root. So anytime you have a pair, you take one number out for it. So here we had 2 2's, so we took out 1 2. Here we had another pair of 2's, so we took out another 2. And then the 3 left over goes under the square root. So if you do 2 times 2, our final answer is 4 root 3. So these two, 4 root 3 and square root of 48 are equivalent. This is just a simplified way of writing it. It's more accurate than changing it to a decimal. Question 2, we're going to do square root of 72. So any two numbers that multiply to get 72 will work. I'm going to do 2 and 36. 2 is already prime. 36 could be like 6 times 6. And 6 is 2 and 3. Again, you want to ignore your big numbers. We're only going to use the prime numbers from our tree. And now we're going to look for pairs. So like here I have a pair of 2's that I can take out. And I also have a pair of 3's. They don't have to be right next to each other, but here this makes a pair of 3's. So that also goes in front. And then we have an extra 2 left over here. So that extra 2 did not make a pair, so it stays under the square root. So this becomes 6 root 2. Let's try square root of 96. So for square root of 96, we could do like 2 times 48. 48 is 2 and 24. 24 could be like 3 times 8 or 2 and 12, whatever comes to mind first. 8 is 2, 4, and 4 is 2, 2. So again, I'm only looking at my prime numbers, so I'm going to scratch out the bigger numbers here. And I'm only looking at the ones that are prime, like 2, 3, and the other 2's. And now I take out pairs. So here I have a pair of 2's. Here I have another pair of 2's. This 3 doesn't have a partner or a pair to go with, so it's going to stay under the square root. And this 2 also doesn't have a partner to go with, so it also goes under the square root. Anytime there's more than one, you just multiply. So 2 times 2 is 4, and 3 times 2 is 6. So that would be our simplified answer. Let's try this one more time with square root of 245. Anytime I see a 5 at the end, I know it's divisible by 5. So I'm going to do 5 times believe this comes out to 49. 49 could be like 7 times 7. 5 and 7 are already prime numbers, so I can't make it smaller from there. And again, we're going to ignore the 49 because it's not prime. So now if I take out my pairs, I have a pair of 7s. And then the 5 is left over, so that goes under the square root. Now, this method works even when they're not square roots. So you can do it for cube roots, fourth roots, fifth roots, etc. So let's look at a few that are cube roots where it has a little 3. So I'm going to start it the same way. It's just we're not going to look for pairs. We're going to look for triples. But for 225, I see it ends in a 5. So this one's actually 5 times 45. 45 is 9 times 5. And 9 is 3 times 3. So once you've made your little factor tree, remember you're only going to look at your prime numbers. Okay. So this one, I didn't realize it wasn't going to work for cube roots. So let's just do it like a square root then. And we'll just do one cube root problem. So it's just going to be a square root. So here, if I look for my pairs then, because it's a square root, I have a pair of 3s. And I also have a pair of 5s. This one actually has nothing left over. So that comes out to 15. So this one doesn't have a radical in the answer. And that's because square root of 225 is actually a perfect square root. It's 15 squared, or 15 times 15. The last one here that we're going to look at is cube root of 256. So 256 could be like 2 times 128. This could be 2 times 64. 2 times 32. 2 times 16. 2, 8. 2, 4. 2, 2. I'm going to erase or scratch out all the big numbers. And we're only going to look at the prime ones. So I'm going to look for, this time, since it's a cube root, you look for triples. So we could take out 3 2s here. Here we have another 3 2s. And these do not make a triple, so they're left over. So that would go under my radical. This time I have to put the little cube root because we're doing third roots. And whatever's left over, these 2 2s go underneath because they could not make a triple. So we end up with 4 cube root of 4. I want to do one more of the cube roots just so you can see it. So let's try doing the cube root of, 144. So we're doing cube root of 144. I'm going to start it the same. I can do like 2 times 72. This becomes 2 times 36, 218, 29, 33. And this time, since it's a cube root, I'm going to look for triples. So I have 3 2s right here. So that makes a triple. And then here I have 2 3s and 1 2, so I can't make any more triples. So that means everything else is left over. So this 2 goes under the cube root. So does this 3. And so does this other 3. So it becomes 2 cube root of 18. So same method, but if you have cube roots, you look for triples and so on.